6.5, factoring perfect square trinomials and difference of squares. So a little bit of vocabulary on this, but perfect square trinomials, this kind of, I don't know, I wouldn't say it's jacked up, but it's new for us, right? So if you ever get something like this format, it won't show in this format right here, like the 2AB. You'll just have to know that it's double whatever the A and B values are. Well, so this is kind of the rule, and if you can notice this stuff right here, I think it takes a lot more experience than what we have, a lot more experience, before you can say, well, look, you can just kind of skip all of our factoring by grouping, then skip to this, okay? And so pretty much all these problems I'm going to be factoring by grouping, then I'll show you how this rule works, okay? Now, kind of the main point here is, at least with the format of these, this is the way that I look at it or memorize it, is that you always got the addition sign right here with your b squared. It's this plus or minus right here that changes. If it's plus there, then you know it's a plus sign between your a and b. If it's minus, then you know it's minus right there, okay? But if it's double these values combined, meaning multiplied together, then you can pretty much take a quick shortcut right here into this format, okay? So a will usually include an x squared. That's true. Sometimes your b squared will have a y squared, like we saw in that last problem in 6.4. I'm not guaranteeing that it always will, but from time to time you will. And it's not meant to throw you off, but it's meant to help you think that you should be able to do those, even with the perfect square trinomial rule, okay? But factoring by grouping is always a certain method to factor these out, even into your perfect square trinomial, okay? So if you're like, look, I don't want to memorize any rule cell, I'm just going to factor by grouping, do it. In fact, I recommend it until you can get used to it and kind of see some of the patterns, which then hopefully will help you to realize that these rules work, okay? Yeah, that's why it says any other method for factoring a trinomial will work. Yeah, and I know that last section, I forgot the greatest common factor on one of them. I'll try to remember to check on this one, and I recommend that you always check and learn from the mistake I made. So yeah, you could have like a 9x squared in the beginning, and then your middle term would have like an x right there. You know, I don't know. Like if this was plus 16 right here, it's a 3 times 4 is 12, so plus 12. I guess 24, sorry.
So is A in
No, yeah, A is the whole entire term, 9x squared. But here's kind of the idea here is that the 9 is a perfect square, so you could have said, well, it was like 3x, all of that to the power of 2, right there. So the A right here would be like the 3x, not really the 9x, but 3x right here. Yeah, I know that doesn't make a lot of sense right now, but I hope when I show the examples on this that hopefully it will kind of make a little bit more sense. But I'm not going to use these rules in the beginning because I just want you to really just focus on factoring by grouping, because like I said, if you can do that, pretty much anything in Module 6 is doable. All right, so let's look at this one. Again, just first, factoring by grouping, and then we'll look at the rule on this one, okay? So factoring by grouping, and yes, this one has a coefficient of x squared. It's a phantom 1. So you could even just use the rule. I'm going to skip that, though, and say, well, look, you got the c value of 9. You could even say at this point, like 9 times 1, that coefficient, right? Just like we did on that last section. And you'd say, well, 9 times 1 it's still 9, right? But factors of 9, well, that would be like 1 and 9, or 3 and 3. That's all we got. And we need that the addition of those to get up to 6. So yeah, I'd say like 1 plus 9, that's going to be 10. That's no good. But 3 plus 3, hey, that's 6 right there. So the 6x I can split up into a 3x and also a 3x. Okay, so I'm just going to show that as x squared. You can show the 1 if you'd like. And that 3x there is positive. And then in the tail end of that, we got the plus 9. Okay, so factoring by grouping, I'd say let's group these two so I could factor out an x there, which leaves me with just the x in the first term and then the plus 3 second term. Okay, and then we can pair these two together. I could factor out a 3 there, which would leave me with just the x, and then 9 divided by 3 is 3. So x plus 3, just like we kind of should have expected from the beginning there, should match that x plus 3. But look what happens. That x plus 3 for the binomial from both terms, I can factor that out. But what do we got left from the from the rest of it. You got the green X, and you got the +3 in orange. And if you were to write something like this on a test, I have to take a point off because it's not considered fully simplified. This is kind of where we get into that
And you just do
perfect
the
square trinomial stuff. Yeah, you have to show this as x plus 3
squared.
squared like this. Then you get full credit, okay? Now, that's using factoring by grouping, and yet some of you noticed, just like we've seen before, since the coefficient was 1, you saw the two factors of 3, you could have just put those in. Just, again, don't forget to narrow that down into its final, most simplified format as x plus 3 in parentheses to the power of 2. Now, what is this perfect square trinomial business? Well, remember, it looks like this, okay? Now, this one takes the kind of the top format there. All right, so let's see if we can demonstrate this, but I got to get rid of this stuff. Give myself some space, okay? So this was our equation. Okay, let's compare these, and then hopefully we'll kind of demonstrate how this works. Okay, so it's a x squared plus 6x plus 9, so this would be x squared plus 6x plus a little 9er, okay? Now, if we do this right, we should get to our final square binomial, and then we should expect addition because we have addition between the x squared term and the 6x, okay? Well, what does this mean? Well, it tells us ax squared, okay? So again, I would look at that term, the x squared. I'd say look at it more as x in parentheses squared, okay? And then the 6x term. So I would say look at this as more like a 2, because remember, we need this 2 here. And then I would say you'd have to multiply it by the x, of course. But also, and I'm skipping a part of that to look at the 9 right now, but the 9 is kind of like a 3 squared. See that? So that's like saying, well, you got the 2 times 3 there as well. Still got the plus sign, okay? So what are, and again, this is, it's a squared. So I can see here that x right here is representing the a. So where I see the a in this perfect square trinomial business, I can put an x. Or, and then I can also see that the b value here is just a 3. So where I see the b in this formula, essentially, I can put in a 3 right there, which is what we found, right? That's what we found before. So x plus 3 squared, same answer, different method. Was it a shortcut? Perhaps right now it's not so big of a shortcut because we have to kind of think through some of this, but, and this may not always work. You say, well, like if this was an odd number, right away you know that you can't use this. But if it's even, then you know that there's actually a possibility that it could work. Last thing I'll mention on this one is usually if I'm looking for perfect square trinomials, I want to see the first term be a perfect square, and x squared by itself is a perfect square. But if it had a coefficient, I would need that number to be a perfect square as well. And so, and then my last term here, whether it's a constant or whether it has a letter, I need to see if it's a letter, it should be squared. But the number itself should be a perfect square. 1, 4, 9, 25, 36, 49, and so forth, okay? So if you're not sure what a perfect square is, it's just any number with any whole number, like 1, 2, 3, counting numbers, right? To the power of 2. 9 to the power of 2 is 81. So if I saw an 81 somewhere in here for the first two terms, I would kind of be looking to see if this will work. Because it is a nice shortcut, by the way. So factor out this business right here. Now, I'm going to show this factoring by grouping, and then I'll show you the perfect square trinomial stuff, which is, I think it's going to be glorious because it's going to give us a nice shortcut on this one. And I'm going to have to take a little bit of a shortcut just really for the sake of time, but, right, because 25, I don't see any greatest common factor on these, so I'd have to take the 25 and multiply it by the 144. And that's going to give us that 3,600, okay? Now, you can find all the factors of 3,600, but I'm going to split it up into 60 and 60, which when I add together, I get the 120t, okay? So the 120 instead, but I can split that up then into 60 of the t's, and then, well, that's plus, and then add another 60 t's, right? So that's the same value, 120t. I'll keep the 25t to the power of 2, and also the 144 there. All right? Then I'll look to factor by grouping. So we'll start with this set right here. And, well, I can factor out a t at least from those two terms, but also 5. Yeah, 5 will work. So 25 divided by 5 is 5. We still got the other t, and 60 divided by 5 is positive 12. But we took out the t, so it's just a 12 now. Okay, then we'll look at the 60t and the 144. Can't factor out a t on that, but I know they're both divisible by 12. So I'll factor out a 12. The 60 divided by 12 is 5, and then we still got the t. And so I know that those are both divisible by 12, but in case you were like, I don't know what the crap to divide these by, just look over here, right? Because you need this to be 5t, so you could say, well, 60 divided by 5 is 12, and then that kind of helps you to figure out what you need to divide the second term by, okay? So 144 divided by 12, yep, it's a positive 12 there, okay? So from these two, I can factor out a 5t plus 12 binomial, and then the second binomial is just whatever's left, the 5t in green, and then the plus 12. But again, these are the same binomials, so I will simplify this into a 5t plus 12, but squared. And that would do it. Okay? All right, now that was real fun to do with factoring by grouping, but, and again, it was fun because I skipped a lot of the factor pairs on that one. All right, so can we use factoring the perfect square trinomial stuff? Yes, we can. And once again, we got a addition between the t squared and the t term. So just look at the first one right there, okay? So let's look at this term overall. We had the 25t to the power of 2 plus 120t plus the 144, okay? Now what we really would like here is to have some value squared plus 2 times that first value, and then the second value, and then add another value that's squared, right? Because then it matches what we have here. Then once we figure out what our a and b values are, we can just fill them into our binomial right here, okay? So 25t squared, can that be some value that's squared? Yes, it can. That would become, that I know the 25, pretty much I'm square rooting the 25. Square root of 25 is 5, and then the t would just be to the power 2. So there's our 5t, okay? And right away I could say, well, I could fill that in right here, okay? Now 2 times 5t is not 120t's, but I still have another factor to put in there, okay? So that's where we look to the 144, which is really 12 to the power of 2. Okay, so I put the 12 there. And what do you get when you do 2 times 5t times 12? You get the 120t. Well, from this then, we can see that the a value here is 5t, and then the b value here is 12. Oh, that's b. So in our perfect square trinomial, try to make that look a little better. Squared right there, you'd have the a value, of course you still got plus between them, but the a value, which was 5t, and then the b value, which was 12, boom, you're done. Same answer, by the way, just a different method, that's all. Now, if you like this perfect square trinomials business, you can think of math nerd somewhere in the history of time. I forget who it was, maybe the Bernoullis, but I don't know. Kind of my recommendation is to almost set it up this way, right? Because like you're saying, you can just square root the 25 and the 144, which pretty much tells you at least the coefficient of the letter or the variable there. And then when you square root that last term, it'll tell you the number. But always plug them in here to make sure when you multiply these out that you will get that middle coefficient at least. Of course, you got the t, so you need to make sure the letter's there, but it should come out pretty smoothly, especially on this lesson, because the name of the lesson is perfect square trinomials, okay? So we should kind of expect these ones to work out for us. But again, if you like doing that, I'm not saying like, but if it works better for you to do the factoring by grouping, then do it. Because it's a valid method, it's a good method. So what can we do about something like this? Well, right out the bat here, and I'm not even concerned about the numbers right now. I just see an x on this last term, but I see x's on all 3 terms. So I would just, right off the bat, I would be looking to factor out just the x at least, okay? Because I from all three terms, I can yank out an x from all the terms. Now for the x's, the first term, that would leave me with an x to the power of 2. The second term would leave me with an x, okay? And then the third term, yeah, we yanked it out, so there's no x for this third term. But all three of these coefficients are even, so I know that I should also be able to factor out a 2. So I'm going to factor out a 2x. That is my greatest common factor. So the first term, you could show the 1 there. I'm just going to make it a phantom 1, make it look pretty. And then the 40 would say divide that by 2, you get positive 20. And then 200 divided by 2 would be positive 100, okay? Now this one's not even too bad because right now, just inside the parentheses, I have a coefficient of x squared that's 1. The a value is 1. And so you could say, well, I just got to find any two factors of 100 and then fill in, remember this, pretty much you're looking to fill in the blanks here. Because you'd have the x and then the x. Of course, you still got the 2x there out there in the front, like this. But all we need is two factors of 100 that add up to 20, right? Well, that'd be 10 and 10 right there. So again, I'm kind of skipping a little bit here to save time, even though I don't really feel like we have to. But then you could say, well, plus 10 and plus 10, right? Just like we did. I think this was 6.2 kind of stuff, maybe 6.1. But then you need to make sure to simplify that into x plus 10. You got two of them though, so squared. Just don't forget your 2x out there in the front. Okay, and this would be complete right there, even without the factoring by grouping or using the perfect square trinomial stuff. I use the rule from whatever it was, 6.2 or 3. Now, since this is the perfect square trinomial section, could we have used it on this one? Yes, we could have. And let's take a look at that. All right, so let's go back to this point. Okay, now I'm not concerned about the 2x in the front. It will stay in the front there, 2x. Okay. What I'm looking to do is to see, especially since this is the section, to see if I can take something and square it. Now, remember the operation between the x squared term and the x term is addition, so I should expect addition right here as well. Okay, what I need to see is if I can make this an a squared plus 2ab plus b squared situation. And it is, by the way. How do we know? Well, remember, you're looking to kind of fill in the blanks here. It's something squared plus 2 times that same something, and then something else plus that last value squared, right? So the x squared, well, that's just x squared. Okay, and you can see the x. I'm going to put it right there a second, so that would be right here. Okay, well, what about that last term? Well, I noticed that 100 is a perfect square. That's 10 times 10, which we've already seen. And so you could say, well, I'm going to make that a 10. And yeah, how do you get the 20? 2 times 10, right? That's the square root of 100. So the a value here is the x. The b value is 10. So x plus 10 would be in the parentheses. That's just exactly the same answer that we saw before, right? That's it. Different method, same answer. So that's perfect square trinomials. I guess we didn't see anything with subtraction between. That's not going to matter because the process will be the same. And if you want to use factoring by grouping, none of this matters, okay, whether you need subtraction or addition between. But this is something a little bit new for us in this section, difference of two squares. So the main thing here, and of course the a or the b could have an x in it or a y, it doesn't matter. But the nice thing is if you see that they're both perfect squares, you can just kind of split them up into these two binomials. Very nice rule if you can understand it or memorize it, I guess. But once again, you can use factoring by grouping even though this is only a binomial. And I'll show you how on this one. If this doesn't make sense, then that difference of two squares thing, that's going to have to work for you because it's hard to say that there's another way to do this. Okay, so here's what I mean. Is remember, when we factor by grouping, we have to make this a trinomial. Well, it's only a binomial. Yes, true. But if I want it to be a trinomial, I can. So I can take my 81z squared and my negative 16. I can separate them just a little bit like this. Okay, and what I want now is a middle term on this. I need it to not have to show up. That's a phantom zero term. In fact, just because I want this to be a trinomial, I'm gonna make that a z right there, okay? So there's no z terms in this one, and that's fine to show it if you'd like to. And since I'm forcing this to happen, I wanna see it, okay? So, well, what the crap does that mean? It means that I can go back in, since it's now a trinomial, I can go into factoring by grouping. So I take my a value, 81, and I multiply it by, it's negative 16 right there. Guess I'll need a calculator for this one, but 81 times negative 16, I get, oh, it's an ugly number, 1,296. That's not very pretty. But I need two factors of negative 1,296 that add up to 0, right? Because that's my middle coefficient right there. So 1,296. Ooh, type that in wrong. I'm going to take a bit of a shortcut here. That's I just square rooted it because I know it'll work. 36 and negative 36, right? If I add these two together, boom, you get 0. Hey, well, that means the 0 could split up into 36 z's and also negative 36 z's. And we just got the rest of this, right? 81z squared. That's a positive 36z. And then the minus 16 right there, okay? Now, some of you guys are like, are you serious? I had to do all that work? Well, I don't know, you have to. If you got that difference of 2 squares business now, then you skipped all this garbage. And I'm still continuing with this garbage, okay? So, yeah, then we're looking for a factoring by grouping. 81 and z squared plus 36z. Let's see, 9, thank you. Yeah, that'd be 9er. If I can get into this. There we go. Yeah, 9 and z, there we go. And so 81 divided by 9 is 9. We took out a z, so it's just z. I'm kind of purposely going slightly fast on this one. 36 divided by 9 is 4, So I'm not showing all the work. We're explaining so much because, well, we've done it before, and hopefully we kind of have that down, okay? So I'm going to have to add those together. I'm going to yank out on this one a negative 4, looks like 4, yep. And then 36 divided by negative 4 would be 9. Of course, it's got the z. And negative 16 divided by 4 is a positive 4. Yep, and I guess I should have expected that because it needs to match this one, right? So then we got 9z plus 4 from both terms. But then we also have the 9z in red. And then the minus 4 here like this, okay? And yeah, we want to, oh, yeah, so this is that difference of 2 squares business, where it's the same values, 9z and 4, but you have different operations between them, addition or subtraction. Yep. Oh, okay, so that's factoring by grouping. Doing this by factoring by grouping, it takes a little bit of, I don't know, ingenuity, some creativity, right? Because most people wouldn't say, I need a plus 0z right there, but you do if you're going to use factoring by grouping. If you ever encounter something like this and you're committed to that factoring by grouping stuff, which is a very legitimate and valuable strategy for factoring out, then do it, okay? On the other hand, though, so difference of 2 squares. Let's look at the original expression here. We had 81. Oh, that's not what I wanted. I do want that there, though. I got 81 z squared minus 16, just minus 16, okay. All right, now, if we can just make this, the first term, something squared, and of course it's already minus between, so we're not concerned about that, but if I can make the second term something squared, then I can fit these values into these two binomials, okay, with an addition and subtraction. It doesn't matter which one you put first. You can make the subtraction here and then the addition there. It doesn't matter, okay? But 81z squared, I can square root both of those. Of course, the z is going to come out very nice. But 81 square rooted, that's 9 because 81 is a perfect square. But 16 is as well. Square root 16, boom, you get 4. Okay, now, again, this original expression there, 81z squared minus 16. I didn't change the value of it, I just changed the way it looked. So the 9z I can see is my, I guess we'd say that's the a on this one. So I'm going to put it wherever I see a in this original expression, so 9z, sorry. Yeah, a's are there and there, so it's a 9z. I put those lines for the z so we can tell they're not 2's, but I realize I'm still not doing a very good job of that. And then the 4 is the b value. So wherever you see the b, here and here, just put in a 4. Boom. And you can see, again, that we end up, and again, this is just by the rule, we end up with the same exact expression that we had back here, right? All right, what about this one? Well, remember the difference of 2 squares kind of looks like this one. One of the main, requirements you need from this is subtraction between. Well, this is addition, so as it turns out, this one, you could even try to show a 0x between there, but this one is just prime. And like I said before, on this section, 6.5, you'll just have to write in prime if you see something like this. I don't know, to me, this is kind of a bigger shortcut than the rule. I like this one. So yeah, for our purposes, we say it's prime. Once you start getting into imaginary numbers, yeah, there we go. Once you get into imaginary numbers, you can actually make this minus a negative on this one. It's super fun, just not really fun at all. Try this one out, then we'll go over it. So let's go ahead and get started on this one. And you'll notice that 245 and 5, neither of these are perfect squares, okay? But just by looking at those, hopefully you realize that 245 is divisible by 5, so you can factor this factor of 5 out from both of these terms, okay? So what are we left with from the first term? Of course, the x squared. And then, I got the minus there, and then 245 divided by 5, 49, looks like, okay? And then at this point, again, I'll skip the factoring by grouping by putting a 0x between these. But I do notice that it's like saying you got x squared here, and then 49 is really 7 to the power 2. 49 is a perfect square. And so that sets up the 2 binomials for us with the addition and minus right here. Of course, you still got the 5 there. But you got the a value, which is x, so there's those. And then you got the 7s from the 49, so there's a plus 7 and a minus 7 right here. And that, that does it for us right there on this one. All right, so something like this one. So all we're looking for on this one, and this one's got addition between it, but it really does have subtraction between it. Here's how. Is just rearrange this, the format here, putting the x squared first. And then, of course, that negative 16 comes in as minus 16 for a term, okay? So, yeah, from here we can see that you got 2 squared terms with subtraction between. The first term here is an x, and the second term here, 16. Of course, you can square root that to get 4, but then you can split that up into your 2 binomials with addition and subtraction. So you got the x's, the a values, and then the b values here are just 4s. Boom, that's it, okay? Now, could we have done that from the beginning? Yes, we could have, as long as you understood that the negative 16 makes it a minus between them. Okay, because the 16, of course, is really just 4 squared. And you could say, well, it's a negative out there in front. But then you got the x squared as well, right? The plus sign doesn't really matter because it makes the x squared positive. And I checked this just to make sure it would work on Canvas, and it does. So if you did it like this, instead, it would still work. So now you got the positive x's right here like this, but then you got a negative 4 and then a positive 4 like this, okay? And, well, are we saying that these 2 binomials are the same as these? Yeah, they are. It's just the order switched, right? So this would be like x minus 4 like this, but switched around, and then 4 plus x, of course, that's just these 2 switched around. It is the same answer, and Canvas will give you credit for either one of these. Yeah, usually what you're looking for is the first term to be the x squared, like this one. So yeah, this one's a little different than that one that had the addition between them. Always try to, my recommendation is to always put it into this format like this with the x squared being the leading term, which essentially makes this in descending degrees, right? There we go. We got a good one with some fractions. Yeah, so fractions are no problem as long as these are perfect squares, right? Because remember the idea here is we're looking for the first term to be squared, and that's not hard because it's just an x right there. We do have the minus between, which is good, but what about this fraction business squared? Well, again, you could look at the square roots of each of these. Like the square root of 25, that's 5, and the square root of 64 is 8. And so really what you end up with 5/8 as a square on this one. And you could have tied this into the calculator with the square root button. That's second, and then it's the x squared button. It's just one button to the left of 7. And it will show you the square root symbol on there. And you can even type the fraction into that square root. It will tell you that the square root of that is 5/8. I know we haven't gone over square roots yet, but I kind of have a feeling you guys understand this stuff already. So if you do, that's good. Because it gives us this shortcut, now I'm ready to put this into the two binomials, the difference of squares, right? So addition and subtraction. You got the x term first, and then we got the 5/8 term second. Boom, that does it. And yeah, expect to see a problem like this with the fractions on the assignment. So for a problem like this one, again, the idea here is to look for something that's squared, right? And then something else that's squared. And of course, we got subtraction between. So yeah, we know it's x squared to the power of 2, because you do the 2 times 2 to get the 4. Square root of 256 is 16. You're correct on that. So let's set this up, right? We got the two binomials. You got addition and subtraction. So the first one, we got x squared, and then we got the 16 both terms. Now the problem with this one is that you now have a binomial here, which is a one of those, not difference of squares. There we go. Had to look it up. So I'm not looking to mess with this first, I don't know, factor right here, if it'll let me move it. But the second one, right, we could say, well, that's like x squared, and this one would be, do a different color, yeah, 4, right? 4 squared, and it's got the subtraction between it, so I can actually split that one up a second time right here with your addition and subtraction, but now it's x's and 4's, like this one. Now this would be considered fully factored.